Welcome to the deep dive. Today we're digging into multimodal reward models. These are the systems meant to help AI vision models get better aligned with what we humans actually prefer.
Right, but there's a bit of a challenge currently. A lot of these models, well, they don't really show their work. They might give an answer, but the reasoning behind it is often shallow or just missing.
And that can lead to reward signals that aren't quite right yet.
That's the issue. There's a lack of interpretability, a lack of transparency, and they often struggle with complex multidimensional judgments. It's a real bottleneck.
So the source material we're looking at proposes a new approach, UnifiedReward-Think. It's described as the first unified multimodal chain of thought reward model.
Chain of thought, or CoT. The idea is that it can handle really detailed step-by-step thinking for both visual understanding tasks and for evaluating generated images or videos.
And there are a couple of core ideas behind it, right? Hypotheses.
Yeah, two main ones. First, that making this long CoT reasoning explicit, actually writing it out, makes the model more reliable, more robust. You can see why it reached a conclusion.
Okay, that makes sense. And the second?
The second idea is that once the model learns this explicit reasoning, it internalizes it. So even when it gives a direct answer without showing the steps, that answer is more accurate because the underlying reasoning is stronger. Implicit reasoning gets better.
Interesting. So for this deep dive, we'll explore how they actually train this model, UnifiedReward-Think, to pull off this kind of complex reasoning using a novel fine-tuning method.
It starts with what they call the cold start. This is the first phase.
Okay, cold start. What happens there?
They use a relatively small amount of data, specifically image generation preference data. And the goal here isn't broad knowledge. It's really about distilling the reasoning style of GPT-4o.
So teaching it how to think, in a way. The structure.
Pretty much. It's about learning the format, the structure of this long CoT reasoning. The paper mentions using specific tags, like think and answer.
Right. Think for the reasoning steps and answer for the final conclusion. So it's learning a structured output format from the get-go.
That's it. Setting up that framework.
Okay, so after the cold start, where does the training go?
Then comes stage 2, rejection sampling. Now they bring in the big guns, large-scale, unified, multimodal preference data.
Unified meaning. Covering different types of tasks.
Yeah, image generation, video generation, image understanding, video understanding, a whole range. The model tries to reason through these examples using the CoT format it learned.
And the rejection part.
Ah, that's key. They only keep the outputs where the model's reasoning process actually leads to the correct final answer.
I see. So if it reasons correctly and gets the right answer, that reasoning path is reinforced. If the reasoning is flawed or leads to the wrong answer, it gets tossed out.
You got it. It's about selectively keeping and learning from the successful reasoning patterns, strengthening those accurate pathways.
Okay, stage 1, cold start for structure. Stage 2, rejection sampling for reinforcing good reasoning on diverse data. What's the final stage?
The third stage is group relative policy optimization, or GRPO. This is where things get quite sophisticated.
GRPO. How does that work?
It specifically uses the samples that the model got wrong during the rejection sampling phase, the ones where the reasoning didn't lead to the correct answer.
So learning from mistakes.
In a structured way, yes. By focusing on these incorrect predictions, the model is encouraged to explore different reasoning paths, alternative ways to get to the solution. It optimizes towards correctness and robustness using what they call verifiable rewards.
Verifiable rewards. Let's break that down. What makes them verifiable?
Well, there are two components they define. The first is a format reward. This is straightforward.
Okay.
Does the output contain the think and answer tags correctly formatted? If yes, score 1. If no, score 0. It just checks for that structure we talked about.
Got it. Ensuring the reasoning structure is present. What's the other reward?
That's the accuracy reward. This looks inside the answer tag. Does the final answer there exactly match the ground truth answer they have for that example?
So a direct check for factual correctness.
Correct. Again, it's binary, 1 if it matches, 0 if it doesn't. And the total reward guiding the GRPO process is simply the sum of the format reward and the accuracy reward.
So the model is pushed to both structure its thoughts correctly and arrive at the right final answer during this GRPO phase.
That's the mechanism, incentivizing both clear reasoning structure and factual accuracy.
Okay, this 3-stage process, cold start, rejection sampling, GRPO, sounds quite deliberate. The crucial question then is, Does it actually work better?
Mhm.
What did the experiments show?
They definitely put it through its paces. The researchers used a whole suite of data sets for evaluation, things like HPD, OIP, video DPO for generation tasks.
And for understanding.
Critic 113K, Share GPT Video, DPO, among others. They really tested it across the board. And the quantitative results shown in their tables and figures, well, they consistently favor unified reward think.
Better than what, though? What were the baselines?
Strong baselines. They compared it against models like Gemini 1.5 Pro, GPT-4o, and other existing reward models specific to vision like Critic, PixScore, Image Reward, and so on.
And UnifiedReward-Think came out on top.
Consistently, yes. Across these different benchmarks for both visual understanding and generation reward tasks, it showed improved accuracy.
Was there anything specific that stood out in the results?
One really noticeable thing was the boost from incorporating that long CoT reasoning, especially for image understanding. It suggests that breaking down the visual analysis step by step really pays off in evaluation accuracy.
And what about that implicit reasoning idea they mentioned earlier?
Ah, yes. They found evidence for that too. After the model mastered the explicit CoT process through training, its ability to make accurate direct judgments, even without outputting the full reasoning chain, also improved significantly. It outperformed baselines even when not explicitly showing its work.
So learning to think step by step makes its gut feeling better, essentially.
That's a good way to put it. The internalized reasoning becomes stronger.
The paper also included some qualitative examples, didn't it, to show how it reasons.
It did. Figures 1, 3, and 4 are quite illustrative. They show the model applying this multidimensional CoT reasoning. For generation, it might look at, say, semantic consistency, does the image match the text prompt, or temporal coherence in videos.
And for understanding tasks.
Things like semantic accuracy, correctness, clarity. For instance, figure 3 shows a robot dog in a maze. The model doesn't just give a score, it breaks it down.
How so?
It assesses alignment with the description, the movement consistency over time, the realism of the robot in the maze, assigning scores and justifying each point before giving a final verdict within the answer tag.
Right. And figure 4 had examples like a tennis player serving, a boy on a bike, showing similar detailed breakdown for understanding.
And figure 5, with the boy eating ramen, also demonstrated this detailed step-by-step evaluation process. It really highlights the granularity of the reasoning.
To really prove the value of each training stage, they performed ablation studies, right? Taking parts away to see the impact.
Standard practice, and very useful here. They looked at the effect of each stage. Cold start, rejection sampling, and GRPO.
And the findings.
The results in tables 3 and 4 show that each stage does contribute positively. Cold start lays the foundation, rejection sampling generalizes and refines, but the GRPO stage seems to provide the biggest performance jump.
Which makes sense, as it's directly learning from the hard cases, the mistakes.
That seems to be the case. It forces the model to refine its reasoning where it was previously going wrong.
They also tried GRPO without the chain of thought component, didn't they? Just rewarding the final answer.
Yes, a crucial ablation. And they found it was much less effective. Just optimizing for the final answer without the guidance of the step-by-step CoT reasoning didn't yield nearly the same improvements.
So that really underscores the value of guiding the reasoning process itself, not just the outcome.
It strongly suggests that, yes, the CoT structure seems vital for efficiently guiding the model towards correct and robust solutions during GRPO.
The appendix also had some interesting methodological points.
A few, yeah. One was about the cold start, using only image generation data. They argue this works because the kind of reasoning needed for images, object recognition, spatial understanding, translates well to videos, which are essentially sequences of images.
So the CoT skills are somewhat transferable from image to video.
That's the idea. Another point was about why rejection sampling is necessary before GRPO.
Why is that?
Well, after the cold start, the model has the basic CoT structure down. Applying the more computationally intensive GRPO to everything wouldn't be efficient. Rejection sampling filters things down, letting GRPO focus on the trickier examples where the model still needs refinement.
Makes sense. Focus the expensive training on where it's needed most.
And finally, they touched on why getting the final answer right during GRPO using the CoT structure validates the reasoning path.
How does that work?
Because the CoT process involves scoring different aspects or dimensions and then combining them for the final answer, if that final answer matches the ground truth, it lends credence to the step-by-step dimensional scoring that led to it. The structure links the process to the outcome.
Okay, so wrapping this up, Unified Reward-Think Looks like a significant step forward. It's this first unified multimodal reward model based on chain of thought.
And its main goals are boosting accuracy and reliability when evaluating AI vision models, whether they're understanding content or generating it.
The training process is key. That three-stage approach of cold start for structure, rejection sampling for generalization and filtering, and then GRPO for fine-tuning the reasoning on tough cases.
With that explicit long code reasoning being absolutely central to the performance gains, guiding the model effectively.
And maybe one of the most interesting takeaways is that mastering this explicit step-by-step thinking seems to improve the model's implicit reasoning too, making its quick judgments more accurate.
Which leads us to a final thought for you, the listener. As these reward models become more interpretable, more transparent, like Unified Reward-Think aims to be, what potential does this unlock for building multimodal AI systems that we can trust more, systems better aligned with human values and judgment?